I'm Bleon. I'm a security engineer, trying to learn as much as I can about infrastructure, penetration testing, and security, both on-premise and cloud infrastructure, and trying to share as much as I can about what I know. So, yeah. Why do we have to test cloud security? Cloud security is an interesting topic, not because it's just new, but also because it incorporates some of the threats that on-premise have, but also it tries to change the way that we have to secure it. First of all, regarding the privileges versus perimeter security. Perimeter security is important on cloud, of course. Perimeter security is important on everything, on every infrastructure, but cloud allows you to also have also allows you to use API to manage everything. So even if you have a security, a perimeter security, even if you have security systems, if an attacker gains privileges of a certain user, he will be able to bypass everything and just do what they wanted to do. So testing cloud is a good thing to start to find a different mindset on how to attack different infrastructures. The three main vendors, the three largest vendors of cloud are AWS, Azure, and Google, GCP. And since we have also Microsoft, people here, Azure sucks, and I have arguments to back that up. Practically on almost everything. But when it comes to the services they offer, even though the names are different, even though probably the technologies might be a bit different, the idea is the same. So everything they offer are kind of the same, except for some differences. So when we think of cloud security or cloud penetration testing, we have to see the differences between them. But at the end of the day, we will see that all of them will be kind of breached the same way. We will kind of have the same path, or the same methodology to test them. Starting with cloud reconnaissance, cloud offers quite a lot of reconnaissance ways because of all the services that they offer and because of all the conveniences that they allowed for themselves. First of all, we have the AWS buckets. Buckets are cloud storages where you can store data and also can be configured as websites, if you want to. And buckets have a specific path that they use, which is the bucket name .s3 .region Amazon AWS.com. So this is not related to your, the account ID of your AWS account is never added, to the S3 bucket. So you can use that to enumerate different buckets based on based on their name. So you can start to look for bucket names or bucket names that might be more possible to be used by that company, and start to check if those buckets are open, so completely open. Usually the ones that are used as applications are fully open. If they do exist but you have no permissions, in the case of a 403 HTTP response, and if they do not exist at all, so you don't have to deal with them. And this is how Nebula usually does it, but as we can see, for the bucket which does exist but is private, we only get the name of the bucket and that's all. But for the bucket which is open, you also get the keys inside that, the object keys inside that. And the object keys are all the content that is inside the bucket, these including the directories too. So each directory is an object too. GCP does practically the same thing, and when it comes to GCP versus AWS, GCP is like they copied the homework, but they changed it a bit, to not, so they will not get caught. When it comes to buckets, when it comes to machines, when it comes to IAM, they kind of did the same, the same thing, and this can be, enumerated in the same way. But they have three domains for some reasons, which you can check. Or you can also leverage OSINT, and as we can see, we just try to check for S3 for a certain region, which is EU.west.3, and it gave us one bucket which is completely open, and as we can see, these are all the objects inside it. So you can start looking for that. So another thing you can add is in URL and some part of the company, and you will start to list, and you will start to list everything that can be a bucket inside of the it can be a bucket used by the company, and you can see if that one is accessible or not, if it's open or not. Azure, on the other hand, does use quite a lot of services, and it has specific subdomains or domains, which later on go to subdomains for each of the services, and it uses the base name, which is the name of the tenant, and everything after that based on the service that you can use. This is one case where we have a container service. We enabled ACR, Azure Container Registry, and it gave us the subdomain of that, so we know that they are using ACR, and also we have storage account, which we can see here from the blob, the file, the queue, and the table, which is the how they manage the data part or the storage part. You can also check if Azure is being used, and we can check if it's being managed by Azure. So something like just your Azure account, or if you have a hybrid account with without federation, or if they are using a hybrid deployment, which it's authenticated using SAML, or which uses the federation. And if you have a federation enabled, you will also have the URL here, which can be used for username enumeration. There is a way to use that. It's not it's not reliable, but you can use that too. You can also get the tenant ID, and you will need the tenant ID when you later on will be authenticated using, especially using service principals. So you can get this one to use just by going to this URL. Username fuzzing is also easy. You can just send a post request using the email as the data to this URL, and it will show you if the user is does exist or not. And you can also leverage crt.sh, which is a website that manages certificates that are bought by a company for different subdomains, for different domains or subdomains. So you can get that to list two subdomains that a company is using based on the certificates that they are buying for their subdomains. Also, each vendor keeps a range of IPs for all of their services. So you can get several IPs or several domains. You can check if those are within that range, and you can see if what kind of services they are using, so that you know what you want to target, for a specific, for a specific scenario or for a specific goal that you have. Now, we'll go a bit on the basics, mostly on the authentication part, which we will later on use for other parts on enumeration and privilege escalation. So we'll start with IAM. IAM use the IAM, AWS IAM includes the users, groups, roles, and policies. Users are your typical users. You just create a user for each of your employees. The groups are just a collection of users, and as on other infrastructures, if a group has a certain privilege, then all the users inside that group have that privilege. The roles are a certain different type of identity that authenticates using a temporary token, which they call it a session token, and the policies are the privileges that you can give to all three of them. So, and they are AWS managed, so you have some policies that are created by AWS that you can use, or you can create your own granular, as you know what you want to add to this user. Each resource has an ARN, and the ARN has a certain format. You will need this because when you do privilege escalation using policies, when you add policy to a user, you will need the ARN of the policy to add, or when you want to actually that's the only reason why I've used it. So yeah, you will need it for that. And to do that, you will also need the account ID, which you can get by making a call from a certain user, or you can actually brute force that. But I don't know if there's any connection between a domain or a company and their account ID like you have with Azure. So that's not going to work. AWS authentication, as I said, AWS authentication uses access key and secret key for users. The access key is a form of ID, and the secret key is a secret string that you have to keep, and you will use it for authentication. So that's the part, like a like an ID and password, kind of like that. You can also log in with username and password and hopefully MFA to the dashboard, so the AWS portal. You can use federation, of course, if you have if you want to log in from your infrastructure, if you have kind of like a hybrid infrastructure, and the web identities, which are OAuth tokens, which are usually used by applications, and I have no idea if there are any other services that use them, but you can leverage API calls offered by the AWS to convert the federation token and the web identity token to access key, secret key, and session token for a certain user. So you will have access to the resources that the user has access to. AWS policies are simple, are granular because each policy is actually an API call. So if we have get user policy, we have an API call even with the AWS CLI that is get user policy. So what you have is what you have. What you have is what you get. The policies have the SID, which is a section name for the policy. They have the effect, which is allow or deny, and they have the actions, which you are allowed to do or you are denied to do. Each user starts with 0 privileges, and the only call they can do is get caller identity from STS just to get the username and the account ID. Everything else is given to you. So it's the idea of whitelisting privileges, not blacklisting privileges. The Azure IAM works using security principles. Security principle is everything that is a user, a group, service principle, which is like service principal names on Active Directory. It's like a service account, and managed identities, which are identities that you attach to a virtual machine or to another service that is allowed to access other resources. These, all of these security principles can get roles, which can be defined by Azure or created by you, and also the scope. So you can add them privileges to a certain service or different services, or you can add them privileges, I don't know, to a tenant or to a subscription. And they will access them, using that. The most common roles, or the most known roles, are the owner, contributor, and the reader. Each service, each subscription, and each tenant has these roles. And the owner is, you have access to everything within the scope that you are given. The contributor can modify the service, but cannot, add or remove privileges to users related to that service, and the reader just reads. They cannot modify anything. The Azure Authentication, on the Azure Authentication, the users can log in using device code, and we will use that as a phishing. We will leverage this one as a phishing, an interactive browser where you just ask to be logged in and the browser will pop up. You log in and the token will be stored, and the username and password, which you can use directly on the portal.azure.com, or anything that you have access to, like I don't know, Office 365, or it depends on if you have an account there. While the service principals use the username and password, use the client ID and client secret, which is kind of the same way that AWS uses the access key and secret key. You have the ID and you have a secret. And client ID and certificate, which is the ID, and the secret is, you don't use the secret anymore, but you use a passwordless authentication. You're using a certificate. And the hybrid deployment. So there are 3. Password hash synchronization, which is the simplest one. You just everything is being all the authentication is being done on the Azure. There is a cloning of hashes from the on-premise to the Azure, and Azure does everything else. Even if your Active Directory deployment goes down, everything will just go on the same. You have the PTA, which is kind of the same, but the hashes are not stored there. But when you do the authentication, Azure will ask the on-premise for the credentials, and the credentials will go back to, the on-premise will authenticate, and then you will get access. And the federation, where everything is being done on the on-premise servers, and then from the on-premise you get access to the Azure. GCP, on the other hand, as I said, uses kind of the same thing as AWS. So you have user, group, service accounts, and GCU domain. Service accounts are kind of like, like the service principals on Azure. And the roles are, the privileges that you can attach to a user, group, or a service account. Everything is the same after that. And yes, the projects are the groups of resources that can be used by a principal on a certain, when you want to. For example, you can create a project that can allow user to access just the virtual machines, I don't know, and the storage, and another project will allow a user to access the containers and I don't know, the storage, and you can, manage everything from them. The GCP authentication. Now, the users are authenticated using either username and password and federation, while the service accounts have a JSON file which has the name, the project, they have a certificate, they have the private key, so they have every information that is needed for authentication, and this is used when you want to authenticate as that service account. And since service accounts are used by are not used by users usually, and the authentication is not directly done by the user, usually this is stored somewhere, and then the authentication will happen usually by API. So if you want to find, you should check this file. The GCP policies, they're kind of the same as the AWS. They have the members that can get access to the policy. They have the condition, which is allow these these privileges to only be available for 1 week, or during this time period, and after that they will not have privileges anymore. Are like I don't know. I forgot how the AWS called them, permission boundaries from AWS. And of course, the part of the role is what you are, the privileges that you get. Now, the initial access can happen in many ways. So you can find credentials in source code, use from public repositories or from private repositories where you have the token, from which you have the token from. You can get the credentials, I don't know, from phishing, from password spraying, from credentials storage, probably you are an insider attack, the credentials. You can do the typical phishing that we do with, I don't know, Modlishka or Evil Nginx. Also, you have other forms of phishing that are allowed by the vendors. allowed. This is usually in the case of Azure. And you have the machine identities, which, as I said, are identities that are attached to a certain machine to allow access to certain resources, and this can be accessed by a call to an API on an IP that they have. And after getting that, you can authenticate as that. You can practically access the same resources that they have. You can use eDoor for I don't know, like you have a share and you have a file that is accessible. I don't know. And you can also use vendor support tickets. Now, sorry, I did not include that because that meant I had to open a ticket to the vendor, and there will be a lot of hurdle to explain them that this was just for for a conference. But when support ticket is open, sometimes a lot of information, sensitive information, is given. Now, if you have a certain application, say an application that does support ticket, that manages the support ticket, something, I don't know, custom, you can leverage those credentials to list all the support tickets, to list all the communication between the vendor and the engineers, and try to find different, different information regarding your company. Sometimes even, I don't know, credentials or access to different resources, or I don't know, So you can use that. It's like, looking at an email, looking at the user's email, but I don't know, different. Now, password spraying on Azure is a feature that Azure, gives you. It's by default, and does happen because you can send a request using an email and a password, and you will get a code based on that, which gives you information regarding the user. If the user is valid, if it's not valid, if requires MFA, if the user is locked, is disabled. So you also get information regarding the user, which is the password is correct, but you need MFA. The password is correct, and you don't need MFA, or you have incorrect credentials, but the user does exist. So you also get information from that, even without getting the necessary credentials. There is a configuration which now is by default, but before it used to be off by default, which was the security defaults, which requires users to enable MFA after 14 days, or requires administrators to enable MFA. It stops you from logging in from legacy protocols, which attackers say that they are using this to bypass MFA. I couldn't reproduce that, sorry. I tried to reproduce that as as an attack. It always said failed. I don't know why. Probably it's my fault. But there are a lot of articles from attackers saying that they can log into an email using I don't know, something like Evolution, which is a Linux email client. And by using the legacy protocols, they can access that email and they can access sensitive information. Now, device code phishing. Device code is a way to authenticate as a user. So you request a code, you can then get that code, put it to a site on Azure, include your credentials, and then do another request, and you will get the access key, the access token, and the refresh token. Now, you can leverage this as a phishing attempt, because you can send a request, get the code, send an email to the user requesting them to log in using that using that code, and then get the access token for yourself, so you practically get access as them. And this is how you can do it. You can just get the code using the request. The target can add the code, can log in, and you can actually use any ID that you want. Azure keeps them private, but researchers keep them public. So you can use the Microsoft Office, you can use the PowerShell module, you can use the AWS CLI. So you choose whatever you want, it will do practically the same thing. And you will get here the access token, and down here, after this, you will have the refresh token, but the screen would not be, would not show more. And this is also truncated, of course. But you will get the IDs, sorry, the tokens from the user, so that you can reuse them. Another thing you can do is create an application, give it permissions, ask a user to request to that, to log into that, and you can get access to the okay, yeah, and you can get access as that user. Rio Sherry did a tool called Office 365 Attack Toolkit that does practically that, and gets the emails of users based on different keywords. So you create the application, you send it to the user agrees to log in, and then you can get information from him without you doing anything, without even having the credentials of the user, without even having the tokens of the user. Now the cloud enumeration, when you do IAM enumeration, you have to look for the security principle, the user group roles, and the user groups that the users which are in a group, or the groups on which a certain user has access on, so that you can get information on that user. Now there are cases, and this actually here is also recommended by the AWS. There are cases when an administrator will give a user certain privileges. Like get his own policies, or get his own users, or sometimes even list users, so that it's easier for them to work without the need of the administrator. And I built a module for that, which allows you to enumerate the user just by the those default ones, I would say, security, those privileges that the user can get. Also, the Azure allows each user access to the portal, which none of the other vendors allows, which gives you gives you access to look at information like Azure AD information, gives you access to look at subscription information, gives you access to look at other resources that they can use, so that you can gather information just by logging in as a certain user. When it comes to storage, we have to look for which buckets and objects are allowed, which are public, and which objects are accessible by the user. So you can have a bucket which by itself is private, but different objects are public, so you can leverage them to get information. And there have been a lot of cases when this kind of files have excluded credentials to allow user to access. Now the virtual machines. As I said, the virtual machines have their own managed identities, which you can access using the metadata API, using the IP 169.254.169.254. And also, when enumerating virtual machines, you have to understand what kind of infrastructure the company is using. So what they have deployed in it. If it's just some servers and an application, if it's a servers application and load balancing, if it's a whole infrastructure behind it. You have to know what kind of machines are being used, what kind of network configurations is being used, and of course the privileges that managed identities will have. So the machine metadata, as I said, is on port 169.254.169.254, and it will give you information on the access key ID, the secret key, and the session token, which you can use to authenticate with that user. Now, there are cases when the SSM is one of them, the systems manager, when you are obliged to add a certain role to the machine identity, and that role has also other privileges, like for example the SSM role for EC2 for the machines has access to enumerate, to list all the buckets and to put and to get objects from a bucket. So you can practically get information just by a role that is mandatory by the vendor. So you can leverage stuff like this to get access. Also, machines like if you have something like a Terraform, I don't know, main node, or like an Ansible main node or something, not Ansible because that uses SSH, but if you have something like Terraform, you they have managed identities, most of the times they will have administrator access. So you can leverage that to get access to an infrastructure just by an API. And this is how you get the metadata. Also, the AWS has two versions. Version 1 doesn't have any authentication and is vulnerable to SSRF. If you find an SSRF on an application, you can make a request, you get the information. The version 2 requires you to authenticate from the machine, so you the only way to do that is by having a remote code execution to the machine. And this is the version 2. The user data is a list of kind of a snippet of code. Sorry, how much? Oh fuck! Is a snippet of code which is run each time a machine is restarted. So you will always find credentials in that. You will always find the snippets of codes, and if you manage to update them, you can also use that to get access to a machine. So this is something you also need to check. What kind of user data is being used on a machine. Cloud functions are code that is ran when a certain event is happening, is like WMI for cloud, and you can choose your own event to use. And this is also nice because usually these kinds of codes have high privileges because they have to access a lot of resources. So you can enumerate, you can get the roles. Same as the machines, they also have roles assigned, so you can get them. And you can get the policies attached to that. And on cases of cloud functions, they use serverless authentication, so the credentials will not be stored on the usual places, but not usually, but always they will be stored on the environment variables, which will be used later on as a form of persistence. Privilege escalation. Now, you can do privilege escalation. So Rhino has a list of about 26 privilege escalations on AWS and some on GCP. I will, go through only 2 of them. So attaching policy to a user, which has the rights to attach policy to other users, and add user to a group which has administrator rights. So first of all, we have a user which only has IAM full access, so they can update the IAM. Even if you had more granular access, you could also do that. And just by attaching the administrator access, and that's where you need the ARN, just by attaching the administrator access policy to that user, we got admin rights as that user without actually breaching any other user. So we just managed to get one credential and got access, administrator access. We did it. Also, we can do that with groups. So we see that this admin group, which most of the, there's a high chance that these users will have administrator rights, which, as we have here, administrator access, is not, that user is not part of that group. But if we add it, we can allow that user to be administrator again just by abusing one simple privilege. Azure Privesc, we can leverage a lot of ways to do Azure. I'm just using one. If you have contributor rights to the virtual machines, which, as we said, can do modify content from a certain service, if we leverage that and execute a command on a certain machine, we can get the managed identity from that, and we can check this if we have privilege escalation. So we can also use something like that to get access to the machine. Exfiltration, the best way I found, which is silent, it's completely normal, even the vendor will not care about that, is just copying data from one bucket to another bucket. Simple as that. You have access to that, you copy to another one, you get information. And since this is a completely normal behavior, because there are times when you do backups, there are times when you do, most of the times backups, or when you want to migrate to another, I don't know, to another cloud or something, you will always do, you will always transfer data. So just passing data from one to the other will not alert many security vendors. And if you manage to obfuscate it enough, you can pass, small amount of data. You can, I don't know, you can name the buckets, in a way that is completely normal for a company or something. You can make it, a good way of exfiltrating data. Persistence. On AWS at least, each user has two sets of credentials, because the secret key is only given once to you. So if you lose it, you have to create another one. And if a user has only one access key, you can create a second one, and with the second user, you can log in as that and have the privileges that the user had. Also, you can, if you know that you are not breaking something, you can delete one of them and create another one and still do the same thing, authenticate as that user. You can persist, as I said, with machine user data, just update the user data, and when it restarts, it will run. You will get access, or any code you want will run on that with administrative rights, so with high privilege rights. Cloud functions, you can leverage something, you can inject a simple code that just does a curl with the attacker's IP and the environment variables, in which we said we have the managed identity credentials, and it will send them to you. You can go on and do everything you want with those credentials, and you can keep that also as a persistence, because those privileges can change, with time. So you can reuse them as many times as you want. And lastly is the golden SAML. It's like a golden ticket bot for federated services. So practically with that you get a token that is, that you get access to everything you want with any user that you want. It can be used as a privilege escalation, just like golden tickets, but mostly it's used as a persistence method. And this, it's like the ultimate persistence. You get access to that. It's like you're getting domain admin rights to an Active Directory domain, but you do that for the cloud. So these are some resources. The PDFs will be shared, so you can check them. And this is the end. Sorry I took you way too long. Sorry, I know.